Welcome back, Year 6, to some more mental multiplication strategies and awesome facts. This is a continuation of the last video, so hopefully you're ready to learn a little bit more and use it in your everyday maths. So in the last video we were looking at multiplication and some strategies. Well, there's one more to go, and we dealt with it a little bit today, and so let's just cover it one more time. 39 times 3. Now I'm not really sure that's a number that we can halve and double because that's going to give me decimals. Not so sure splitting it as 30 times 3 and 9 times 3. There may actually be a quicker way of doing it, and that's going, hold on a moment, I can bump 39 up to become 40 times 3. Well, I know what 40 times 3 is. It's 4 times 3 is 12, so that must be 120. But I didn't want 40 times 3. I've actually made it 1 3 too many, or I've actually got one extra 3. So to work out the answer to 39 times 3, I'm going to take away 3 from that. The extra 3 that I sort of invented to make the sum easier to do in my head. So 120 take away 3 is 117. Hey, that's pretty cool. Do you notice that what we try and do all the time where we can is make numbers into a multiple of 10 or 100. We can do these in our head. So, what about if I had 38 times 3? Well, again, what I would do is I'd say, well, let's make that 40 times 3, which we still know is 120. But how many extra 3's did I have? Well, I went from 38 to 40, so I had 2 extra lots of 3. So to get my answer, I've got to take away those 2 lots of 3, or take away the 6, to give me 114. This again is another great, funky idea, and it's used a lot with money. So for example, say I bought a magazine for $19.98, and then I decided, well, actually I'm going to buy 3 of them. How would I do that in my head? Well, I'm pretty sure what we would do is say, well, $19.98 is pretty close to $20. I'm going to multiply that by 3 to give me $60. And then what did I do? Well, I added on an extra 2 cents 3 times. So I've got to take away 6 cents from that to give me $59.94. How cool is that? All right, so that's now pretty much the end of multiplication. What's the opposite of multiplication? Division. To learn division, what we try and do is we look at the ideas of multiplication first. So, let me think. 6 times 7 is 42. Yep, we like that. So, what is 42 divided by 6? Well, what do you notice? Here's a 6 on one side, here's a 6 on a different side. Same thing, the answer actually works out to be 7. Maybe you already know that 42 divided by 6 is 7. But, this is interesting. What about 42 divided by 7 then? Well, this time the 7 has moved over, and what does it leave on its own? It's left the 6. Interesting. Does that work all the time? Pretty much, yeah. 9 times 3. 9, 8, that's 27. So, what is 27 divided by 3? Well, yeah, look, the 3 is on the other side. What does it leave? It leaves 9. And in the same way, as if I do 27 divided by 9, what do I have left? Just the 3. So this is where knowing your times tables comes in really, really important. Okay, so, well, I was just talking about the idea of numbers swapping sides. Now maybe this is a little bit further. This is something we talk about normally in Year 7, but maybe some of you have already noticed that a times by 6 on this side moves over and becomes a divide by 6 on the other. The times by 3 here moved over and became a divide by 3 here. So if I have 36 divided by 3 equals something, I can think of that in a different way. I can say, well, hold on, my divide by 3 can sit on the other side, but it has to become a times by 3. So what number times by 3 is 36? Well, hopefully you'll all think 12. So my missing number is 12. So 36 divided by 3 is 12. Interesting. Well, like this. Okay, that's pretty cool. Do numbers always divide properly? What if I had 25 divided by 6? Is 25 in my 6 times table? No, it isn't. 24 is. So, how many 6's are in 25? Well, we decided 6, 12, 18, 24. There's 4 will go in, but hold on, we've got 1 left over. We've got 1 just strangely on its own. And the way we write that in primary school or junior school is R1. Now that R stands for the word remainder. And it means, well, it goes in 4 whole times and remainder 1, or there's 1 left over. Now in secondary school, we don't tend to use remainders. In fact, you'll never use the word R, again, really, all the way through until VCE. It seems a bit weird that actually we start introducing remainders back into VCE maths. And for those of you who are interested, just remember the words polynomial division. Yeah? Division using letters. That's weird if you've ever wanted to know. Right? But it's also a lot of fun. Now there are ways of doing division using the same idea as multiplication. So for example, if I wanted to do the answer to 68 divided by 2 in my head, we can always use the same idea as we did for 68 times by 2. Now I know we can all times by 2 on our head, but if you think about it, we could have done 60 and 8 and multiplied both of those by 2. So 60 times 2 is 120, 8 times 2 is 16. Add them together, you get 132. Right? Again, easy example, but it works in the same way for division. 68 is the same as 60 and 8. And this time you divide that by 2 and divide that by 2. So what is 60 divided by 2? 30, because that's half. What is 8 divided by 2? It's 4. And if I add those two together, what do I get? I get 34. And as we probably already know, 68 divided by 2 is 34. Wow, if I keep using all this in my head, imagine all the ticks I'm going to get and the fabulousness and the 100% in my tests. And your mum and dad will be really, really happy and they'll buy you a car. Maybe not when you're 11 or 12, but you can always hope later on, right? So there are different ways of doing division, all right? So that one was using the split strategy. There's another one called the factors strategy. Ooh. What is a factors strategy? So using the idea of factors, let's just have a quick think about what factors are again. Covered in a previous video, but it's not a bad idea to look at it again. What are the factors of 18? Well, we know that we can use a factor pair, and we know that 1 and 18 are factors, 2 and 9, 3 and 6. Any others? 4, no, 5, no. There we go. So we've now created my factor pairs. Right? And it's very important, the factor pairs. Remember, the reason 1 and 18 go together is that 1 times 18 gives me 18. What does 2 times 9 give me? 18. What does 3 times 6 give me? 18. So these factor pairs are really, really important. But why are they important? Well, 18 can be split up into 2 and 9, and it can be split up into 3 and 6. Well, how does that help me with division? Look at this example. 216 divided by 18. Now, most people would probably grab a calculator and go, oh, no, too complicated, don't know how to do that. But we now know that 18 can be split up into 2 and 9. So what I can actually do is I can now break this problem up into 216 divided by 2, and whatever answer I get, I then divide that by 9. Now, if you ever get stuck on a video or ever not sure what happens, stop it, look at the screen, rewind it, keep replaying it. That's the idea of doing these videos. So you can stop, go back, rewind, play, pause, ask someone for help. Ask someone to explain it to you, maybe someone at home, because these videos are online 24 hours a day. So where did I get the divide 2 and divide 9? Remember, 18 can be split up into 2 and 9. Divide by 2, divide by 9, because I'm dividing by 18. So, what is 216 divided by 2? It's 108. Because when you divide by 2, you're halving. And what is 108 divided by 9? Hold on, 108 is in my times tables. It's in my 9 times table, and I know it happens to be 12 nines. So 108 divided by 9 is 12. Right? I can't do that in my head. I'm 147 years of age, and I can't do that in my head. No idea. But I can half a number and then divide that by 9. So we can use an idea of factors with different questions. So let's look at 564, and I'm going to divide that by 12. Right, well, the 12 is the number we need to look at, so I'm going to find the factors of 12. 1 and 12, 2 and 6, 3 and 4. Remember, 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. So, we're not going to use 1 and 12, they're silly numbers, because if I divide by 1, I get the same number, and that would be weird. Right? So just to say, if I had to do 564 divided by 1 gives me 564, and if I divide that by 12, I'm back to my original sum, and that's just silly. Makes no sense at all. So what about 2 and 6 or 3 and 4? Well, I quite like 2 because I can halve numbers. So let me think, 564. So I'm now going to do that 12 is the same as divide by 2 and divide by 6. So 564 divided by 2 gives me, what does that give me? 282. 282. So now I'm going to do 282, which is that answer, and divide it by 6. Why am I dividing it by 6? Remember, divide by 2, divide by 6. We've done the divide by 2. Now I'm going to take my answer and divide by 6. Well, 282 divided by 6. How many 6 is going to 28? 6, 12, 18, 24. So there's 4, 24 with 4 left over. How many 6s are in 42? 7. So there we go. It's 47. So I can now say that 564 divided by 12 is 47. Possibly could have done that a different way. I could have used the 3 and the 4. But why? We've got a way through there. That seems pretty cool to me. In one of the booklets you're using, there's something called the rules of divisibility. Now these are actually pretty interesting rules and something that maybe you should look at learning because it will make your life so much easier. Many of you out there have already learnt the Roman numerals, which I think is pretty awesome. All right, so let me think. Rules of divisibility, what does it mean? Well, let's look at the number 2. Which numbers can be divided by 2? Well, really, later on in life, you'll work out that really all numbers can be divided by 2, but they don't all give a whole number answer. So what we say is that any number that is an even number can be divided by 2. So 2, 4, 6, 8, 10, 12, 14, 16, and so it goes on, can all be divided by the number 2. What about the number 4? What rule is there for the number 4? Well, it says it will be divided by 4 if the last 2 digits form a number that can be divided by 4. Wow. So, for example, 412. Can that be divided by 4? I'm going to tell you now. Look at the last 2 digits. You've got 12. Can 12 be divided by 4? Awesome. There you go. So, apparently, if the last 2 digits can be divided by 4, then the number can be divided by 4. What about the number 5? Well, that's an easy one. Everyone knows that one. Any number that ends in a 0 or a 5 can be divided by 5. That's pretty cool. All right. The number 10. Well, any number that ends in a 0 will always be able to be divided by 10 into a whole number. And the same with 100. Any number that has 2 zeros at the end can be divided by 100. There are 3 other rules, but I'm actually going to leave those for you to discover. Right? The information's in the booklet. I need you to read it. Don't just dive straight into the questions. Have a go at reading, because all of the information is there for you. In the last video, we looked at the idea of multiplying by 10. So if I had 43 times by 10, I said we don't bang a 0 on the end. Right? We don't do that. What do? Well, we think of the number as 43 with the decimal point on the end. And when we multiply by 10, we move the decimal point one place to the right. And so we do the whole, and there's my decimal point. What's it jumped over? Well, there's nothing there, and you're right, there is nothing there. So 43 times 10 becomes equal to 430. And we found out that this also works with decimal numbers. So if I had 27.3, the decimal is already there, so I don't need to put it at the end. If I want to times that by 10, it's got 1 0, so it moves one place. The decimal point moves one place. The decimal point moves one place to the right. So let's just check. 27.3, it jumps one number and ends up at the end. So the 2, the 7, the 3, the decimal point is at the end, but we know we don't need to write that. And so that's my answer. That is equal to 273. The same thing actually works with division. But let's just think. I have 230 and I'm going to divide by 10. Well, when we multiply by 10, we notice the decimal point moves one place to the right. And some of you very cleverly picked up that the reason it moves one place is because there's only 1 0. If I multiply by 100, the decimal point will actually move 2 places. And if I multiply by 1,000, it's going to move 3 places. And if I multiply by 10,000, it's going to move 4 places. I wonder how many places it will move for 1,000,000. Good question. Because multiplication and divide are the opposite of each other, then if when we multiply we move that way, guess which way we move when we divide? Yes, we move the other way. So we move backwards. So same rule, 1 0. This time it's going to move backwards one place. So we have 230. I'm going to put the decimal point at the end, and this time I'm going to bounce it. So it appears between the 3 and the 0. So I'm going to write it out now by putting the decimal point in between the 3 and the 0. And we know from all the work we've done previously that we don't actually have to write the point and the 0 at the end. It doesn't exist anymore, or it becomes hidden. So my answer now becomes 23. Ooh, what's up? One more example. 64.7 divided by 10. Well, the divide sign means it moves to the left. There's 1 0, so it moves one place. So let's see. There's my decimal point. It's going to jump to between the 6 and the 4. So I'm going to write the decimal point between the 6 and the 4, and there's my 7. There's the answer. Job done. So 64.7 divided by 10 gives me 6.47. We can even do it with trick decimals. 0.43 divided by 10. Ooh, see how many of you get this one? Well, we divide by 10, so we're going to move it that way, one place. There's my decimal point. It's going to jump to in front of the 0. So now let's write it. There is my decimal point. There is my 0. There is my 4. There is my 3. Well, we've not been tricked because we know that we don't leave a decimal point just sitting at the front of a number. We have to put a 0 in, and that's your answer. You now can tell me that 0.43 divided by 10 is 0.043. I love this bouncing decimal stuff. It is awesome. All right? And it's used all the way through school. We even use the same ideas in VCE and A-level. Now, I think that's pretty much enough for today. So, I think you've got more than enough work to get on with to enable you to carry on through the booklet we've been working on. Good luck, Year 6. I look forward to seeing you some point soon. Have a good day.